All right, hi guys. We are going to go over the practice problems that I assigned last class. I'm going to go through both the radical way of writing it with the square root and with the estimated decimal version as well. So whichever one you used, I will show you both answers. So starting with the first one. First one, we had a right triangle. And one leg was 3, the other leg was 7. So I'm just going to go and assign a to 3 and b to 7 using the Pythagorean theorem, a squared plus b squared equals c squared. These are a and b, so I'm going to replace 3 with a. 3 squared plus 7 squared equals c squared. 3 squared is 9. 7 squared is 49 equals c squared. Those two, when added together, gives me 58, which is equal to c squared. And then to isolate c, I need to take the square root of both sides. So then I get c on this side, when we take the square root of c squared, is equal to the square root of 58. Then I would go check and see if the square root of 58 can be simplified. I happen to know that it cannot be simplified into anything further that will be able to be taken away from the radical. So we're going to just leave it as the square root of 58. And the decimal version of that answer is 7 approximately. So I'll actually change it. Instead of the equal sign, I'll say it's approximately equal to 7.62. All right, that's the first question. Now we're going to move on to the second. I'm going to keep the Pythagorean theorem up there, the formula for all of these problems. Okay. So we have that still there. Now our next right triangle was a little bit taller and skinnier. I'm not drawing these perfectly to scale, just doing a quick sketch. So one leg was 5, the other leg was 2. I'm going to make 5a and 2b. So it's going to become 5 squared plus 2 squared equals c squared. 5 squared is 25 plus 2 squared is 4, which equals c squared. Then we add 25 plus 4, which is 29, equals c squared. And then we take the square root of both sides, so we isolate c, giving us just c on this side and the square root of 29 on the other side. 29 is a prime number. It does not break down any further, so we don't simplify it. And then if you wanted to estimate it in its decimal form instead, you would get c as approximately equal to 5.39. Alrighty, moving on. So then we had a question that was another right triangle. This one was a little bit wider. It was a right triangle. One leg was 3, the other leg was 10. 3 was the value of a, 10 was the value of b, let's say. Like I said, you can go back and forth. So a is 3, so it's going to become 3 squared plus 10 squared equals c squared, because we're looking for the hypotenuse. So c squared becomes 9 plus 10 squared is 100 equals c squared. We add 9 and 100 together to get 109 equals c squared. Then we want to get c all by itself, so we take its square root. We get c on this side because the square root and the square cancel each other out. And we get the square root of 109. Then if you want to, we can estimate the decimal version depending on what the directions say. I didn't give you specific directions, so you had freedom to choose here. So the decimal version of this answer is c is approximately equal to 10.44. Now, the square root of 109, once again, does not break it down to any other factors that will allow us to pull them out of the radical, so we can keep it as is. Okie dokie. Moving right ahead, we have a right triangle that was kind of drawn a little differently, but the right angle is at the top, so it has 7 and 10 here. Those are both still the legs. The hypotenuse is always opposite of the right angle, so we still are dealing with just the legs here. A will be 7 and B will be 10. we have a squared plus b squared equals c squared. So that's 7 squared plus 10 squared equals c squared, giving us 49 plus 100 equals c squared. 100 plus 49 is 149 equals c squared. We take the square root of both sides. We get c is equal to the square root of 149. When we check to see if it can be simplified any further, it can't, so we leave it as the square root of 149. And the decimal version of that answer is c is approximately equal to 12.21. Alrighty. So a lot of these problems are really similar, right? We just did the same type of problem over and over again. The next problem we're going to do is different from the rest. It's different for two main reasons. So here is our right triangle. This side is 3.9 and this side is 11. So it's different, first of all, because we're dealing with a decimal, so 3.9 is probably not a number you can square off the top of your head easily. So that's one reason why it's different. It's also different because we are not dealing with two legs. We are dealing with a leg and the hypotenuse. And we're looking for a leg. So I'm going to give these different letters. I'm going to give A 3.9, and I'm going to give 11 is going to be C. We're going to be looking for B in this situation, not C. So now we're going to use our formula again. A squared plus B squared equals C squared, but we're not going to just autopilot and submit the two numbers we're given into the beginning. We have to remember 11 is relating to C and not B. So 3.9 squared plus B squared equals 11 squared. 3.9 squared, for those of you that don't have a calculator next to you, is 15.21 plus B squared equals 121. Then we go ahead and to solve this, we're going to subtract 15.21 from both sides. It'll go away over here and we'll be left with B squared is equal to 105.79. Then to get B all by itself, we'll take the square root of both sides. B will be isolated and we'll have the square root of 105.79. This definitely can't be simplified any further. It's a decimal as is, so we're just going to keep it as that. Or if you would like, you can find its estimated value. So B is estimated at its decimal form of 10.29. All right, so that's how we do the 5 practice problems. If you had any trouble with those or maybe didn't understand how I got an answer, hopefully this answers those questions. All right. So now we're going to move on to today's lesson.